Okay, welcome to this next video, estimation and approximation. Again, our learning goal is still where the students will be able to solve problems involving comparison, addition and subtraction of integers. And at the end of this, you should be able to round integers to a given place value and use different strategies to provide reasonable estimates. Okay, so why estimate? This is a good question. Now, mostly a good idea is to sort of say, right, how far is it from maybe where I live in Caboolture to school at Rothwell? Okay, maybe let's go, how long does it take me to get there? Well, on a good morning it might take, I would say it takes maybe 25 minutes. Now, is it going to take me exactly 25 minutes every time? Probably not. Maybe one time it does take exactly 25 minutes. But would it help you at all if I said, oh, well, it takes me 23 minutes, 6 seconds, and 57 milliseconds? Does it help you at all to say that? Does it help me to time the amount of time it takes me to get to school down to the seconds or the milliseconds? It doesn't really, I don't need to have a stopwatch to help me get into hundreds and thousands of a second. Okay, so we estimate by just saying, oh, it's about 25 minutes to get to school. Okay, so estimating can help you to simplify things and to give you a better judge to sort of create areas, costing things, timing things, and measurements of stuff. That's where estimation really comes into its own. All right, so key ideas. We can provide an estimate of a value by rounding to a given place value. Okay, so 10, 100, 1,000, etc. So you might be asked to say, well, here's the number, 2,346. Okay, and you're asked to round it to the nearest 100. Okay, so what that means is that we get, this is one way to go about it, we get a line, and the 100 that's where we're breaking the number. Okay, so these numbers aren't going to change, these ones here. Okay, now we turn our attention to here. This is sort of our critical digit. Okay, because that's one that depends upon what happens to the rest of this number. Okay, now if the critical digit is from 0 to 4, okay, then we simply truncate the number with zeros. Okay, so truncate means just to chop off. Okay, if that critical digit is from 5 to 9, okay, we add 1 to the rounding number, the rounding digit, and truncate. Okay, so 2,346. We have a look at our critical digit here. 4. It's in this one here. So that means we simply truncate this number with zeros. So we'll have 2, 3, truncate it with zeros. Okay, so 23,000 is approximately 2,346. Okay, so let's say 23,000, 2,300. I don't know. Okay, let's go through now to leading digit approximation. Okay, so what this means is that we simply round the number to the place value of the first digit. So if it is 93,521, when we do leading digit approximation, let's make this somewhat interesting. Let's make this a 7. Okay, 97,521. When we're doing leading digit, well, that's where we're cutting the number off, and we look at our critical digit here, 7. That's from 5 to 9, so that means we're going to add 1 to the rounding value, this 9 here. Okay, so 9 plus 1 is 10. Okay, then truncate the rest of the number with zeros. 1, 2, 3, 4. Okay, so 97,521 is approximately 100,000. Okay, so that's how we go about that. Right, now remember this new symbol with our relational symbols. This one here shows a relation approximately equal to. So we should be writing from before 97,521 is approximately equal to 100,000. Okay, so this means the value on this side is kind of the same as the value on this side. So approximately equal to, close to it, a little bit of error there, but within the margins that are acceptable and sort of stipulated by the problem we're looking at. Okay. So again, if this is something familiar to you, I really want to encourage you to move into the should and could level questions, and I'll look forward to doing these exercises with you at school. Okay, thank you.